So we'll start off got it in slice mode. So what do we get for images? We've got some pseudo-sagittals, some pseudo-long axis, and some pseudo-short axis. So let's grab our localizer and start by creating a better sagittal localizer. It's not going to be a perfect sagittal localizer for now, but it's something to start with. Notice how I'm going right down the second metatarsal, which is fairly parallel with the rest of them that we can see in this particular oblique plane. So we'll run this for now. We're not quite in the ballpark yet. We parked our cars in the parking lot, trying to get into the ballpark. Once we get into the ballpark,
down Yankee Way,
we will prescribe our true imaging plane. So here's a decent looking sagittal, off of which we can now do a decent short axis. So with that short axis, we want to be perpendicular to the long axis of the metatarsal. And we'll take a few slices. Just a few, really, not 56. Again, none of what we're positioning is a true short axis or a true long axis or a true sagittal. We're just getting into the ballpark now. So here we have a short axis view where we can see all the metatarsals, off of which we're going to prescribe a long axis view. So we'll go perpendicular off of our newly prescribed series. And since we're looking at the mid to forefoot and the lateral side, we're going to get our slice and angle it through the majority of the metatarsals. And clearly, as you go from the hind portion of the foot more towards the forefoot, that angle changes slightly. So you're going to try to pick a happy medium, which is about there. So here we have a pretty good long axis of the foot, as you can appreciate by viewing the long axis of the metatarsals. So now we will bring this down yet again, and we'll go down to our one slice, and you can see if we copy image position to that first pseudo-sagittal that we did, we're not too far off here. But look at our angle on the short axis. So when we go perpendicular on our newly prescribed long axis, watch what happens to this angle here. So now that's truly sagittal in both planes. Your sagittal off of your long axis, and your sagittal to the mid to lateral metatarsals on the short axis view. makes a big difference. Okay. So if we want to prescribe a couple of slices, we can. So at this point, we sort of arrived into the ballpark, okay? And so watch the difference between this image and that image.
Oh, nice.
Okay? So now, we'll bring our short axis view down that we did earlier, and we're going to be perpendicular to this. And you can either eyeball it the way we're doing it, or similar to the technique that I showed you in the shoulder, if you go parallel with the long axis and then protocol turn group, that'll put you perpendicular also. Okay? And now you can see that we're not only perpendicular perfectly off the sagittal, but off of the long axis as well. Now this is definitely a lot of scouts, but if you don't prepare ahead of time, your obliquities will never be as accurate as you want them to be. And when it comes time to utilize your second localizer, the yellow box, it'll be more of a true representation of what you're angling to versus something that's obscurely angled. So here we are here. And now we'll go perpendicular to this image here, which now you can see not only are we parallel to the plane of the metatarsals on the short axis, but look how parallel we are on that image as well. So we usually go about midway. Accordingly. So now we have a good short axis localizer. We're getting a good long axis localizer. And then we'll prescribe one more final sagittal localizer. So we have, when we prescribe our true imaging, we will get a second localizer box that accurately depicts what our field of view is. So here's, and can you see the difference now compared to before? So much better representation. And then we'll go perpendicular here and here. So now we have a well-prescribed sagittal localizer, long axis localizer, and short axis localizer. Yes, it took many steps to get there, but from an imaging perspective, the benefits far outweigh the small amount of time spent. And clearly, if I wasn't explaining things to you, I would be going through this a lot quicker, and this scouting process takes far less time. So the first thing we'll do are what we call coronal oblique T1s. These are the short axis cuts. Okay, again, depending on the facility, they'll call them either axial or coronal. Just keep in mind, it's technically speaking the short axis. Okay, so when we say short axis, we're talking about this imaging plane here. Okay, so for now, I'm just going to copy image position to this, which should get us right where we need to be. And we want to cover from the tips of the toes, at least to the tarsal bones. So I'm going to add just a few more slices. Bearing in mind we want to make sure we get through the base of the fifth metatarsal. So even though we might be through the to the tarsal bones here, we might just be falling short. See how we would be if we just took this one image for granted? So the base of the fifth metatarsal tends to go a little lower than the rest of them. So here we are at the tips of the toes. We're covering into the tarsal bone, so we got the tarso-metatarsal joints, and making sure that we cover the base of the fifth. Okay? And here, since we have this same angle, we're now getting a nice accurate depiction of what our field of view looks like. Okay? So we can center accordingly. So this sat band here isn't saturating anything because it's in the air. So we want to go and make sure that our sat band, we're going to flip that to parallel feet. Okay? The F and the H just means head and foot, but in the case of extremity work, especially with different obliquities, it's really irrelevant. You just want to make sure your sat band is placed where it will be beneficial. Out in the air is clearly not beneficial. What's the goal of the sat band? At least the single sat band is to saturate pulsatile arterial flow. So I just moved the sat band over the direction from which the arterial flow is coming. Okay? So now we have our sat band appropriately placed, we have our positioning done accordingly, and we have our second localizer angled and placed accurately. So we're ready to go. A couple of adjustments. Hey Sarah, the scan is 5.5 minutes. The next thing our site does is a coronal oblique T2, or once again a short axis T2. So I'm going to copy. So we can actually do slices for this. Wait, it'll change the number of slices. So it changed it, but it also concatenated it. And we can concatenate if we want, or we can just go down to one concatenation. We'll just do one concatenation. And then the next in line is the coronal oblique stir. Which again, we'll take slices because we changed our number of slices. And the slice thickness and gap is the same between the T1, the T2, and the stir, so we can use the copy slices option. And we can apply that. So we're done with the short axis imaging. Next we will do our axial oblique imaging, or long axis.